Y2K isn't the only problem with the way we represent time. Y2K was the expected bug in software that converted time starting with a 19 to a 20, and was predicted to lead to anything from a few slight inconveniences to a complete collapse of society. The year 2000 came and went largely without any software problems, but that doesn't mean that there aren't any more foreseeable problems in the future. The first is the so-called Y2K38 bug, in which the date may change from January 19th, 2038 to December 13th, 1901. To understand why such an unexpected change may occur, let's look at how software measures time. Currently, Unix time is the most largely used way to reference time in software, which counts the number of seconds that have elapsed since January 1st, 1970. Many computers use the signed 32-bit integer as the system time. This means the value can be either positive or negative, and covers a range of time as great as 32 binary places allow. What's interesting about this way to represent time is that in 2038 there will be so many seconds elapsed since 1970 that 32 bits simply won't be large enough to represent it, and clocks will wrap around to a large negative number and begin counting up to 0. Of course, 2038 is a few years away, so we have enough time to create a solution, so programs won't experience this problem. However, there is an immediate problem with programs that work with dates in the future. Many analysis programs track things for decades and extrapolate this information to the future, so 2038 could be a much more immediate problem than it seems. Of course, when you look to the future, other problems arise as well. Just like the Y2K bug was a predicted error in the conversion of time, the Y10K problem involves a transition from 4 digits to 5. By the year 10,000, of course, it's nearly impossible that any computers or programs produced today would still be functioning, so it may seem like only a theoretical problem that computer scientists have nearly 8,000 years to solve. However, even today it becomes a problem for people who use such large spans of time regularly, such as astronomers, chemists, and geologists. One proposed way of dealing with this problem is by placing a leading 0 in the date. Although it's not very popular currently, it is gaining increased popularity among some circles, including the Long Now Foundation. Other than having a name that sounds like an ominous secret organization, this very real group is actively changing the way we think about the future. They have a number of projects, including the Clock of the Long Now, which is an actual clock designed to keep time for the next 10,000 years. It's made out of mostly valueless material and placed in a cave in order to be sure it won't be looted or destroyed in that span of time. But even the Long Now Foundation isn't considering the next big problem, the Y100K bug, when years aren't represented in 5 digits but 6. Of course, this is so far away that it almost seems absurd, and isn't even useful in most models. Humanity will even likely have another system for measuring time in place by then. But even more distant in the future are the problems with 64 and 128-bit Unix time wrapping around. However, these dates are so distant in the future that they are greater than the predictions of the end of the universe. Please remember to subscribe, and thank you for watching.